Sorry for the interruption. Actually, the technical glitch was happened to the technical end. So kindly reconnect. Ask your friends and all other faculty members, and please ask to reconnect. Due to technical issues, the meeting was ended.
पवार मॅडम लेक्चर होते दादा. पवार मॅडम लेक्चर होते म्हणलं आता. मोबाईल सुरू करून ठेव त्याचा.
Yes, ma'am. Your screen is now visible.
Yes, sir, it's visible.
Yes, ma'am. Your screen is now visible. You can start.
Okay.
Okay, ma'am.
So come to the radiation. Radiation is the energy that travels in the form of waves or particles and is part of our everyday environment. Radiation is everywhere. It is in the air we breathe, the water we drink, and the food we eat. See this figure for radioactive atoms, energy, radiation, and particles. Now, life and radiation. All life is dependent on small doses of electromagnetic radiation. For example, photosynthesis and vision use the sun's radiation. Peoples are exposed to radiation from cosmic rays as well as to radioactive materials found in the soil, water, food, air, and also inside the body. Man-made radiation sources are widely used in medicine, industry, and research. It can be either useful or harmful. See this figure: atom, nucleus, proton, electron, and quark. Nature and origin of radiation. There are various kinds of radiation which can be classified in electromagnetic radiation and particle radiation. Ionizing radiation, visible non-ionizing radiation. So here cosmic rays, gamma rays, X-ray, ultraviolet, infrared, radar, FM, TV, short wave, holds low from high to low. The types of radiations: non-ionizing radiation and ionizing radiation. So in case of non-ionizing radiation, ultraviolet, visible, infrared, microwave, radio and TV power transmission are there. And in case of ionizing radiations, the radiation capable for producing ions when interacting with matter, X-rays, alpha, beta, gamma and cosmic rays. The non-ionizing radiation sources are ultraviolet light, visible light, infrared radiation, microwaves, radio, and TV power transmission. The non-ionizing radiation examples are ultraviolet black light induced in fluorescence in some materials, vision, very small portion that animals use to process visual information, heat, infrared, a little beyond the red spectrum, radio waves beyond infrared, microwaves, electrical power transmission, 16 cycles per second with a wavelength of 1 to 2 million meters. And ultraviolet sources are sunlight. Most harmful ultraviolet is absorbed by the atmosphere, depends on altitude, fluorescent lamp, electric arc welding can damage the eye, corona, germicidal lamps, eye damage from this light, and skin cancer. The ultraviolet effects are high ultraviolet that kills the bacterial and other infectious agents, and high dose causes sunburn, increased risk of
Excuse me,
skin
ma'am.
cancer,
Sorry to
pigmentation
interrupt.
that results in
Hello.
certain
Ma'am, sorry to
lotion,
interrupt. Again, the presentation is not visible.
radiation. That,
Okay, ma'am.
high ultraviolet kills bacterial and other infectious agents. High dose causes sunburn, increased risk of skin cancer, pigmentation that results in suntan. Suntan lotion contains chemical and absorb ultraviolet radiation reaction in the skin to produce vitamin D that prevents strongly absorbed by air, thus the danger of hole in the atmosphere. Now visible energy, the energy between 400 and 750 nm, high energy, bright light produces of number of adaptive responses. Standards are set for the intensity of light in the workplace measured in candles or luminance. The infrared radiation, the energy between 750 nm to zero point 0.3 centimeter, the energy of heat. Heat is the transfer of energy, can damage corona, iris, retina, and lens of the eye. Glass workers, glass blouse contact, microwaves and radio waves. The energy between them is zero point 0.1 centimeter to 1 kilometer. Variety of industrial and home uses for heating and information transfer, radio, TV, mobile phones, produced by molecular vibration in solid bodies or crystals. Health effect: heating, long-term effects being studied. The electrical power standards in homes and business, highest level of exposure from electric power generation and distribution system, high voltage power line, medical system, magnetic imaging, acute health effects, shock, long-term health effect appear to be few, but may some data to suggest adverse effects. The ionizing radiation, ionization means separation of ions. For example, NaCl, Na plus plus Cl minus. Here, the ionization in a radiation capable for producing ions when interacting with matter. In other words, enough energy to remove an electron from an atom. Now the sources are X-ray, radioactive material produce alpha, beta and gamma radiation, cosmic rays from the sun and space. The ionizing radiations, see this figure, alpha, beta, gamma, paper, plastic, steel and lead sheet is there. Now, radioactive material, they are either natural or created in nuclear reactor or accelerator. The radioactive material is unstable and emits energy in order to return to a more stable state, that is particles or gamma rays. And half-life, it is nothing but the time required to disintegrate half of its original substance. It is half-life, time for radioactive material to decay by one half. Alpha particles, two neutrons and two protons, the charge of +2, emitted from nucleus of radioactive atoms, transfer energy in very short distance, 10 centimeter in air, shielded by paper or layer of skin. Primary hazard from internal exposure, alpha emitters can accumulate in tissue, bone, kidney, liver, lung, causing local damage. And beta particles, small electrically charged particles similar to electrons, charge of -1, ejected from nuclei of radioactive atoms, emitted with various kinetic energies, shielded by wood, body penetration 0.2 to 1.3 centimeter, depending on energy, can cause skin burns or be an internal hazard of ingested. The gamma rays, electromagnetic photons or radiation identical to X-rays except for sources. Emitted from nucleus of radioactive atoms, spontaneous emission emitted with kinetic energy related to radioactive source. Highly penetrating extensive shielding required, serious external radiation hazard, and X-rays overlap with gamma rays, electromagnetic photons or radiation produced from orbiting electrons or free electrons, usually machine produced when electrons strike a target material inside the X-ray tube, emitted with various energies and wavelengths. Highly penetrating extensive shielding required, and external radiation hazard, discovered in 1895 by Röntgen. Radiation units, exposure, uh, absorbed dose, gray, amount of energy absorbed, and equivalent dose, uh, make different sources of radiation equivalent, severed. And standards, US National Council on Radiation Protection, International Council on Radiation Protection, ICRP and NCRP, occupational exposure guidelines. So here 100 millisievert over 5 years, average 20 millisievert per year with a maximum of 15 MSV in any 1 year. And general public background, about 3 millisievert per year, guideline 1 millisievert per year. The ionizing radiation health effect, the use of high energy ionizing radiation is continuously increasing in many sectors like industries, medical diagnostic centers, nuclear reactors, nuclear research establishment, etc. Above certain levels, electromagnetic fields can be harmful to health and affect the human body in different ways depending on their frequency. Thus, The actual problem is when the people exposed to large amount of radiation in extraordinary circumstances, as they have this deleterious effect on human life and other materials. The categories of exposure are occupational exposures, public exposure, and medical exposure of patients. So, in case of occupational exposure, exposure of workers incurred as a result of their work, with the exception of excluded exposures and exposures from except activities, medical exposure, and background. And in the public exposure, all exposures of the public other than occupational exposures and medical exposures of patients. Medical exposure of patients incurred by patients as part of their own medical or dental diagnosis or treatment. Volunteers helping in the support and comfort of patients and biomedical research volunteers. The reducing exposure, time, distance, and shielding. So, in case of time, reduce the spent near the source of radiation. Then, distance, increase the distance from the source of radiation. And for shielding, place shielding material between you and the source of radiation. Radiation protection, different types of radiation detectors, monitors, and personal dosimeters are used for radiological protection by the measurement of X or gamma rays. See this system, these are these sources. All these are the sources. And this is gamma ray spectroscopy system with software and computer. The scintillation counter. One of the earliest method of detecting nuclear radiation was the luminescence they produce in certain substances. In 1903, Crookes in England and Elster and Gittel in Germany independently reported that alpha particles impinging on zinc sulfide screens produce individual flashes which could be observed through a microscope. The first attempt to count alpha particles by observing flashes of light scintillation generated in diamond by them was made by this E. Regner in Germany in 1908. So scintillation counter since 1945, this old technique is now playing a most important role.
Hello, ma'am.
This has been due to the development of photomultiplier tube and intensive study of the luminescent properties of many inorganic solids as well as organic compounds, either in the solid state or in solution. A purely systematic diagram A purely systematic diagram of a scintillation counter unit is shown in figure. So see this scintillation counter here, photomultiplier tube. What is scintillation? Scintillation means flashes of light. And in case of scintillation counter, there is a photomultiplier tube. This is called as a photomultiplier tube because its function is to multiply. In PMT, that is photomultiplier tube, there are diodes from 1 to 10 or 1 to
Hello, ma'am. Hello. Your voice is not clear, ma'am.
Dr. Ram, sir, please call to ma'am and ask her.
I did, sir.
होतोय का?
Hi there.
आवाज आला?
Yes, yes, you are audible and visible.
This photomultiplier tube, there are the schematic view of scintillation counter. Here scintillation counter, this PMT, and the PMT is present in the scintillation counter, X-ray, gamma rays, NaITL crystal, that is sodium iodide doped with thallium, and PMT, these are the diodes. It consists of the luminescent material known as scintillators, reflecting layers such as aluminum foil enclosing the luminescent substance or facilitate the collection of light pipes, the photomultiplier tube, amplifier, voltage discriminator, and an electronic circuit uh, to record the output pulses. Before considering the performance of the scintillation counter, let us first examine the behavior of some of its components. The photomultiplier tube. In modern scintillation counters, human eye is replaced by an electronic device called a photomultiplier tube. It is a high sensitive photocell converting light energy into electrical energy. In one of the commonest type of photomultiplier, a semi-transparent CSSB cathode is deposited on the inside of the end of a high vacuum envelope. Cathodes of this type have a maximum response to light at the blue end of the spectrum. The photoelectrons ejected from this cathode are accelerated towards the electrode D1, that is first diodes, and are collected by the electrode where they liberate more secondary electrons. Photomultiplier tube. These are focused on the electrode D2. The process is repeated in several stages by focusing the electrons from one surface to the next. These collecting electrodes D1, D2, etc. are called diodes. A photomultiplier tube may have as many as 13 or 16 diodes, each one being maintained at a positive potential of 100 volts with respect to the previous one. The total voltage drop across the whole system is supplied from the rectifier power pack. This photomultiplier tube, high energy photons, ionization track, photocathodes, focusing electrode, PMT. These are the diodes, connector pins, scintillators, primary electrons, secondary electrons, dynode, anode, photomultiplier tube. The dynode as a blind structure and is covered with a layer of material with a high secondary emission coefficient such as CSSB or AGMG. The number of electrons reaching an anode A is thus a million or more times the number of electrons reaching the first dynode. The anode A is connected to the positive voltage supply through a series resistance R. Because of the voltage drop across the load resistor, a negative output pulse is produced by a flash of light falling on the photocathode. Photomultiplier tube. This pulse can be recorded by scalars. At room temperature, there will be an appreciable emission of thermionic electrons from the cathode to produce undesirable current known as a dark current. This noise can be discriminated if the initial light pulse is sufficiently large. When very weak light pulses are to be detected, the dark current is reduced by operating the phototube at a very low temperature. Scintillators. The principal method of excitation are in this luminescence, incandescence, and luminescence. The former refers to radiation due to temperature of the source, and the latter refers to all types of radiation due to cause other than temperature. The luminescence caused by photons are named as photoluminescence and are further divided uh, into phosphorescence and fluorescence. When the visible or ultraviolet light is emitted within 10 to 8 seconds or less after the radiation absorption, the emission is called fluorescence. Fluorescence, phosphorescence refer to delayed light emission, which may follow the radiation absorption by minutes, days, or even years. The substances which scintillate when bombarded by radiation are named as scintillators, also called phosphors, are mainly classified as organic crystal. This employed a large clear crystal of the organic substance naphthalene as phosphor. The crystal surrounded by thin aluminum foil is attached to the top close to the cathode of the photomultiplier tube. Following this, it has been found that other related organic compounds consisting of several linked benzene rings are better scintillators. Of the solid organic scintillators, anthracene and steel when appear to the best on account of the larger output pulses. The organic crystalline scintillators have a faster decay time, that is 10 to 8 seconds, nearly 10 to 8 seconds, high transparency, but a poorer conversion efficiency, especially for heavy particles because of low Z and rho. These crystals have low cross section for photoelectric and pair production process. We know that these are the interaction processes. There are so many, but out of these, only three we are going to consider as a main interaction process: photoelectric effect, Compton effect, and pair production. So, photoelectric effect, if electrons are fall on the K, it is called as a K shell photoelectric effect. And in case of pair production, there is a creation of pair. And what is Compton here? When a photon of energy h nu it is falls on the target material, then scattered photon is having energy less as compared to incident photon energy, because some part of energy is going to recoil electron. It is a Compton effect. So here for photoelectric and pair production process thus cannot be used for the detection of gamma rays and X-rays. They are very good for recoil neutron detectors. Recoil neutrons detection. Organic liquid. Certain solutions of organic compounds are also capable of acting as phosphors, although they are not as efficient as the best pure crystals. The liquid is scintillators has two main components: the solvent, for example, toluene, phenyl, cyclohexane, or xylene, and the primary solute. For example, a few percent of diphenyl or terphenyl. When the scintillations occur in the extreme ultraviolet region, one use a wavelength shifter. A small amount of secondary solute must be added in the liquid for this purpose. The wider choice of secondary solutes has been provided by this performance of these liquids is quite sensitive to the presence of impurities in the solvent. Plastics. This organic scintillator system, which lies between a solid and a liquid, has a plastic as the base. A solution is made of the primary solute with the addition of a wavelength shifter in a solvent like vinyl, toluene, or sterylene, which can be readily converted into a solid plastic. The resulting transparent material can be made in large pieces and cut to any desired shape. Plastic scintillators are widely used in high energy physics. Most of the commercially available phosphors are claimed to have pure height 60% that of anthracene. Inorganic crystal, and this organic compound inorganic substance do not scintillate when they are pure. The most important sodium iodide activated with thallium, about 0.1%. A less sensitive alternative is the no hygroscopic iodide, also activated with thallium. Calcium iodide with a trace of europium is more efficient than aniline, that is silver activated zinc. ZNS sulfide is an excellent scintillator but can be used only in these layers because it soon becomes opaque to the light emitted by it. Its main applications has been in the study of alpha particles. NaI crystal, in crystals such as NaITl, an ion Tl replaces an ion Na plus and forms an emission center. The Tl plus ion thus occupies a position of equilibrium in the lattice such that a displacement from that position produces an increase in potential energy for the entire lattice system near the thallium ion. Tl plus ion. The absorption of radiation changes the Tl plus ion to an excited state for which the potential energy curve has a minimum at a position different from that in the ground state. The absorption transition A leaves the system in a state of high vibrational energy. See this lumination process in NaITl. This potential energy y-axis, x-axis there is a distance. The merits of NaITl crystal, it has apparent for ZNS, that is zinc sulfide, the highest value of CIP, it is nearly 8.5%. It can be grown into large single crystal of more than 10 inches in diameter and 10 inches in height. Its emission spectra has an average value of wavelength nearly 4100 angstrom unit, and FWHM, that is full width at half maxima, it is 850 plus 100 angstrom unit. So what is this FWHM? Suppose here we are plotting in x-axis there are number of counts and y-axis. So maximum counts are suppose 10,000. Then draw a line between middle, that is 5,000, and a value between these two, that is full width. Full width 10,000. So half maximum minimum is middle is 5,000. So draw the two perpendicular line to x-axis and find that width, that is called as a full width at half maximum. 100 angstrom units. Its absorption spectra lies in ultraviolet region with the peaks at 2340 and 2930 angstrom unit. Due to this reason, these crystals are highly transparent. The merits of TL crystal. 6 is because of high values of rho and Z. It has large cross section. Okay, what is cross section? It is sigma total. That is total interaction cross section. It is obtained by calculating the value of mu, that is linear attenuation coefficient, and mass attenuation coefficient. And how they are obtained? By primary equation. Del I, change in intensity is directly proportional to incident intensity and change in thickness. Now, in order to remove that proportionality sign, take some constant, and that constant is mu. So del I, it is equal to mu into I delta x. X is nothing but a thickness, and I is the intensity. Del means difference. So here difference in intensity, that is primary intensity and intensity after transmission, and that mu is nothing but a linear attenuation coefficient, that proportionality constant. And if we divide this linear attenuation coefficient by its density, that is rho value, then we can obtain the mass attenuation coefficient. So this is the basic parameter, linear attenuation coefficient, and can be calculated by substituting the value of density of that particular element or compound or mixture. And finally, the total interaction cross section, that is sigma TOD. It can be calculated by substituting the value of mu by rho, and the unit of cross section is bar, 1 bar. Due to this reason, NaITL is very suitable for the detection of gamma and X-ray. So for research purpose, generally NaITL, that is sodium iodide doped with thallium, this NaITL crystal detector is used. And for more accurate, we can use also the silicon lithium detector, HPG photon detector. So it is since Na is very hygroscopic, the crystals are therefore encapsulated. The crystals are very brittle and very sensitive to temperature gradient and thermal shocks. Interaction of gamma rays with matter. What are gamma rays? The electromagnetic photons or radiations emitted from nucleus of radioactive atoms, highly penetrating, causes serious radiation hazards. These photons, for energies lower than 15 MeV, there are three main processes by which photon interact with matter. So these are the photoelectric effect, Compton effect, and pair production. I have already explained about that. These are the three main interaction processes: photoelectric, Compton, and pair production. So in case of this photoelectric, what happens? The electrons, these photons falls electrons, this is conducting surface, and emitted electrons, the Compton scattering. Here the photon of energy h nu is falls on, this is a target material, this is less as compared to incident photon energy. Why this reason is that? Because it is some part of the energy is going to recoil electrons. So this incident photon energy, it is a combination of both this scattered photon electron, scattered electron energy, and scattered electron energy, and scattered photon energy. So both combination, it gives the incident photon energy. It is in Compton scattering 0.1 MeV to 10 MeV. And pair production here, there is a formation of pair electrons and positrons when a gamma ray photon is incident on this target nucleus. Photoelectric effect. Incident photon is totally absorbed and ejects electron from the atom. This effect dominates with low energy photons interacting with heavier elements. And in Compton scattering, the electron is also ejected, but incident photon surface and is scattered by losing some of its energy in water or biological tissues. This effect dominates at energies above 50 keV. And in case of pair production, uh, in which in this process, in which its energy is converted into electron positron pair, this interaction starts occurring at energies higher than 1 MeV. Unlike electron, positron will eventually disappear, annihilating one electron of surrounding material. Positron electron pair is converted into two photons with energy of about 0.5 MeV. Now see the softwares for shielding effectiveness. Which softwares are using for that? We determine shielding capabilities of materials experimentally using different detectors based on their interaction with matter. We can determine shielding effectiveness of materials that are constantly needed to protect human and life from these effects of radiation theoretically. So how these theoretical values are obtained? It is obtained by XCOM program, WinXCOM, auto Z effect, this PHX mu dot. So first we will see what is XCOM. Here this is a database. It is possible to obtain photon cross-section data for a single element, compound or mixture by using this XCOM program. How to run this program? Suppose we want to find out the XCOM for element chromium, this compound. So we have to first identify whether it is element, compound or mixture. Then write the symbol for that element. Write only symbol or atomic number. If we are going to write both atomic number as well as symbol, then we are not able to obtain that data. So only insert the symbol. For example, chromium we have inserted. Then method of entering additional energies are, there is a optional. Option is appear that enter the energies, enter additional energies by hand. So this range is from zero point 0.01 to 1.5 MeV. Generally, in our lab, we are going to use the sources from 10 kV to 1500 kV, because this energy range, it is used in medical field to detect the cancer treatment, and also for agriculture field, for food preservation, soil sample, rock sample, for cancer detection, uh, to decide the radiation to be delivered without any harm to normal cell. It is necessary to have a precise knowledge of this gamma ray interaction data. So how much radiations are to be delivered so that we can detect the cancer? So that amount we are detecting in by using this NITR detector. And also for food preservation, we are using this
Ma'am, you are not audible to us. Ma'am, hello. Hello, call, ma'am.
She might having any connecting issue.
Just a sec. Hello, ma'am. Hello, participants. Ma'am has some technical issues. So, ma'am has finished their lecture. All are requested to please submit your. Thank you, ma'am. Thank you so much for your nice presentation. Thank you so much.
If you have any
Uh,
queries or any questions, please ask.
Any questions from participants?
Recording in progress.
I think there are no questions. So thank you so much, Honorable Power Ma'am, for the nice talk given to our participants. Now I request Mr. Sikand sir to please go to the vote of thanks. Mr. Sikand.
Thank you, Dr. Ram sir. So I would like to thank all the resource person, Dr. Professor Dore sir, Professor Yashotekin sir, Dr. D.K. Gaikwad sir, Professor Power ma'am. All the resource person have given their valuable time and shared their valuable thoughts to our to this all the faculty members and all the students. And I would like to thank all these participants who have participated in this 2 days international workshop. So, and I will express my specially sincere gratitude to the principal, Dr. G.K. Kakade sir and Dr. D.T. Wag sir. And all the participants, they should fill their feedback link, which is given in your chat box as well as in WhatsApp group. You will receive all the certificates after 2 days. If you have any query, feel free to ask. Okay. Thank you, sir. Thank you, everyone.
Thank you, everyone for participating in this international workshop. Thank you. Thank you so much.